That square root throws it off,
Yeah.
I think. Hey, but that's what's neat. Sometimes you can do it with two techniques. Any suggestions how to do this?
You can add the exponents.
Brilliant. That one he's basically saying like distributive property. To get through this mess. It's looking weird. You go, what do I gotta do another U sub now? He's just saying distribute this. Because he's saying here, write this. U times square root U plus square root U. He says distribute this. That's what when he said add exponents. And when that's U to a what? 1/2? That's U to what power? 1. So hey, we gotta review. Sometimes these are confusing. Go back to the old algebra days. How did you simplify that back in the day?
Add them.
You added them, right? Remember? Stuff like that, you added powers. So that's U to a 1, that's U to a 1/2. What's 1 plus a 1/2? 1 1/2. What's that as
3
a?
and 3 half.
There you go. There you go. We're just gonna integrate both of these. Right? Yeah, let me just swing this over here because we're running out of room. Let me just keep a wall here, so this is kind of outside of this. Let me rewrite it. You got U to the 3/2 plus U to the 1/2. And here we go, here we go again with the U to the 5/2. I pumped it up by 1 because I'm doing the antiderivative. And then I divide by 5/2. Go ahead, Josephine.
Where'd you get the U to the 3/2?
With this, before I do it, I just want to make sure you're comfortable, like, we got to go back, old school math, algebra, x squared, x cubed. What do you do with these? You do. So you go this, when you have something like this, in this scenario, you add the powers. So when you and I, he thought to distribute this, he's talking about take this exponent and add to that exponent. That one has, Josephine, a 1. This one has a 1/2, and 1 plus a 1/2, 3/2. That's where it's coming from. And so ours, I'll do this again. U to the 5/2 over 5/2, which means I can flip this and do what? Yeah. Some of you, a lot of you automatically do that, don't you? You just like 2/5, U to the 5/2. Pump up a 1/2 by 1, that's 3/2. Now, this time I won't do it. Could you tell me what happens when you divide 3/2? Multiply what?
2/3.
I'll see. 2/5 U to the 5/2 plus 2/3 U to 3/2 plus C. And what was U again?
X minus 1.
Okay, so this is going to look weird. But this is the answer. Ready? 2/5 x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3. It does look weird though, huh?
So now,
You don't get many of those though.
so number 69, should we take like natural log of x as what you say?
Let's do it.
U?
Good eye, I like that one.
Yeah.
Oh, and he dove into the textbook. If you got your textbook available, let's do some of these. This is a good one. It's got an L and X in there. Now what's the derivative of L and X?
1 over x.
1 over X, right? Can I raise?
Mhm.
Everyone try this. Alright, I like that one too.
Yeah.
That's a good one. First of all, I want to show you something, everyone. When they write it like this, Josephine, this is how it's presented in this problem. This is number 69. You see this? They put that there? Absolutely. If you prefer to look at that problem as 1 over x, square root natural log x, and put the dx where? There?
Mhm.
Definitely do it. If you prefer that. I can't tell you how many times teaching calculus over the years, that's what threw the student off. They go, oh, if I knew that, I could have got the problem on the test. Just that simple concept. This was bugging them. How this was up here, and they were used to it over here. Threw them off. Threw them off their game. They're used to that. And that kind of thing, like, I left that one blank. The dx up there was bugging me. And I said, oh, just do this. And they go, oh, you're kidding. And I would have got it. So keep in mind, you can always do that. All right, you made the suggestion. What are you letting you equal?
Natural log of x.
All right. Step 1. Step 2. du
1 over,
equals
1 over x dx.
1 over x dx. I'm not doing a step 3 this time, am I?
Nope.
No constants. No step 3, I'm going in right now. We're gonna get it. Go ahead. Oh, you sure? Hey, but look, there were no constants now, so I'm like, stop here. All right, you're replacing the 1 over x and the dx. Just du. And what replaces the element of x? But only radical stays. How do you integrate a 1 over square root of u?
E over half.
Now I've seen this on tests. Can you find my error?
Minus.
Minus negative, u to the negative 1/2, right? To get it up, right?
Mm-hmm.
Right now, it's like, wait, that's u to a negative 1/2. Now pump up negative 1/2 by 1. I love integrating this, everyone. Because if you pump up negative 1/2 by 1, it becomes a half.
Plus 1.
And then when you divide by a half,
It becomes 2.
it looks all sloppy. We're saying just multiply a 1.
By 2.
The reciprocal too. 2 u to the 1/2. That's a nice one, I like that. Because you can put the radical back. Look, a u is a 1/2, I want is something with the square root. Right? Here, let me put my plus c in there. Plus c. 2
Natural log of
square root of.
x plus c.
Now look, I'm not putting bars on that. Students ask me that over the years in calc. Wait, why didn't you put the bars this time? I didn't do this.
1
did I?
over x. Yeah.
Look, I didn't do this. I just let u equal natural log of x. The original u didn't have a bar on the x. This one did. No bars. So yes, that domain would be limited. That would have a limited domain because natural log has a limited domain for that problem.
That's from 0 to infinity, right?
And open parenthesis on to 0.
0, yep.
You can't include 0. So what we're saying, and when I couldn't ask you on this problem to do this, that would make it undefined. Improper integral. Do that in calc 2. In your way. Do that in calc 2. I couldn't even do this. Does anybody know why? What's natural log of 1?
0,
See, 0 and a bar. I couldn't. I have to start this thing where?
2.
At least like 2 or something. Then you do 2 square root ln of 5 minus 2 square root ln of 2, right?
Mm-hmm.
Every once in a while, it's good to go back and talk about definite intervals. Alright. Hey, scan over page 414. I'm gonna look for anything that threw people off over the years. Oh, I think it's always good just to insert one of these. Ready? I love doing this stuff. You just get better and better and better. Because the whole idea is, you're doing all these problems on the final exam next week. All you're going to see are integrals. And you're like, when do I use u-subs? When in doubt, try it. Right? When in doubt, try it. Well, perhaps you try u-sub here. But Bell-Raj, we don't need a u-sub, do we?
Nope.
So we just did u-sub after u-sub after u-sub after u-sub. We're thinking, oh, we just do it every time, but now we're back to this. This is just a little monomial in the denominator. Can't we split this?
Mm-hmm.
We don't need a u-sub. You could try a u-sub, you'd go nowhere. You might think, oh, I'll knock that out. You're not going to get this out of the way. So split it. Right? Split that thing.
2 x to the power minus 2. Oh, sorry. No,
Oh,
professor.
so what's a good way to
No,
write that?
square, x squared, 2 over x
Oh,
squared.
thank you so much.
You forgot an S.
Right up here, he's like, hey, thank you so much. 2x over x cubed plus x squared over x cubed. Alright? That's 2x to the negative?
Mm-hmm.
Is that okay there? Alright. Plus, I mean, I can write it as x to the negative 1, but I think I prefer to write it like this so I know about integrals of 1 over x's. Which one's the ln of x?
The right one.
Jess, I'm just gonna put 1 plus c again.
Wait, what are you doing?
Were you okay that this became integral 1 over x? Natural log x? I didn't integrate this yet, though. Do you see how that became this? Okay, I'll take it slow, I'm gonna do one more step. That would be 2 over x squared, wouldn't it? Do you see that, Josephine? From there to there? Right, an x over x cubed. It's almost like x cubed means 3x is multiplied.
That's just an exponent rule, right? Like if you have an x squared over an x.
Yep. You can do it 2 ways. Do it the way you prefer. Sometimes it's not hard at all just to expand. When you have something like that, I want you to think, well, that's an x over 3x is multiplied. Doesn't something cancel? Sometimes it's fun just to think, well, expansion, that's x over 3x. What would cancel there, Josephine? 1 of the x's, right? But there's another way to do it. If you did that subtraction rule, that would be x to the 1 minus 3, which makes it x and negative 2. So isn't that funny how much this stuff comes into play in these problems? That's when you add. This is when you do what?
Subtract.
Add powers, subtract powers. I don't know if we've seen this yet, but I bet you all know what to do there.
Multiply.
That's when you multiply. You know, just those old rules. Hey, pump that up by 1. Kel, we gotta be careful now. Like
Negative.
derivative or antiderivative? All right, antiderivative. Add 1. So on the number line, negative 2 plus 1 makes it
Negative 1.
negative 1. Okay. Sometimes you gotta stop. You gotta hesitate. Because U subs involve derivatives, and now we're doing antiderivative. Gets confusing. I think we got it. Pump it up by negative 1 and then divide by negative 1.
So it becomes negative 2.
Hey, Josephine, are you okay with this one? I'm just gonna leave it negative 2, because that's negative, but then I'll bring that back downstairs. Because x and negative 1 means 1 over x. That's how I'm gonna write it. Negative 2 over x. That guy. Alright, good.
Wait, what?
Oh, did you see that?
What
Want me to do it again?
Yeah.
Alright, so something's going on here. Whoop. Back it up. Back it up. X to a negative 1 means, I'll add to this list. Means 1 over what? X to the first. So negative exponents, this stuff, it's funny, this stuff becomes important here. That means 1 over x. So I can take, let me hide all that there, Sterling. X and negative 1 means 1 over x. Alright, I'll write 1 over x. But then there's a negative what number? A
Okay.
negative 2. So I'll just write it as negative 2 times 1 over x, which I can write like that.
Okay.
Negative 2 times 1 over x, negative 2 over x.
Can you write it like natural log x to the power x minus 2 divided by x?
Yeah! Oh, did you want to get common denominators? You could. This is fine. But if you got common denominators, you'd have to multiply x over x here.
Yeah,
And you
then
get x, natural log of x, minus 2 all over x. Let me
Then-
put that. It's not a bad idea.
yeah.
I like it, or you write it like that. This is fine now.
X we can also take it as a power too, right?
Right, I want common denominator.
But can I take the x as a power?
Oh, he goes, I'm with it.
Yeah.
Yeah, I like it. Take it there. That worked. Doing a great job. I'll look for another goofy one. Okay. I think you'll get it though. I use this one in the spring. Most students got it. Did you try it? Now everyone, I could have written it like that, but on my test I decided to write it like this. So I'm gonna present it to you in the same way. Try that one. Try to go start and finish on it.
Okay.
You subs. I'll look for another weird one. can do these all in your head. That's pretty darn good. That's pretty darn good. Jess, what would you let u equal to?
I think I did it wrong. And when I said equal to sine x is or
And you just let u equal sine x? That's it?
would you have to do sine x squared?
Never. I wanna point that out. Have you ever noticed with these u subs, I've never done,
First squared.
and note, I want something to kinda key in on. I've never done like u equals square root of something. I've never done u like equal to something squared. It's always been what? Like u equal to secant of x, u equal to sine of x, u equal to x squared plus one. So you were right. You got it. Now let me keep going here. du equals,
Negative.
and it's positive, right? Because we're off to the side, derivative of s is c. So cosine x dx. No step 3, right? Step 1, step 2. Off to the side. Jess, you got it. Let's go in. It's going to work. So look at this. Jess, what is going to replace